Hello, and welcome to the Kansas City Jug. We're talking about event messaging, the best of both worlds. And I have with me Mary Kukleski. And welcome to the Java Use Group. We'd like to thank our sponsors. CRL, or Clinical Reference Laboratory, helps pay for our meetup. And YRC Freight, they helped host the meetings when we were in person. Java News of the Month. We got JDK 18 released March 22nd, and this includes first class internet address resolution SBI, simple web server, code snippets with the @snippet, and finalizers and subject do as deprecated for removal. Releases, we have just Apache Groovy 4.0, and that's the only major release that we could think of. But if you happen to know of any other release, please share. And we have conferences. So we have DevNexus in Atlanta, April 12th through 14th. UberConf in Denver, July 12th through 15th. And KCDC, Kansas City, between August 8th and 12th, 8th and 10th. All right. If you get involved, attend the meetups, tell friends, like and subscribe to this channel, volunteer to speak, and we have a new paper call out there, and I will paste that for you guys. All right. Here's Mary Gugleski, and let her talk about the news event streams.
Sure. Thank you, Justin. Really, thank you. So thank you to Billy too. Billy can't be here today, but thank you. And thank you to Casey Jug. Thank you to everyone who's coming to my talk, whether you're watching it right now, live, or afterwards too. So thanks. So actually, you may notice, actually, if you're being paying attention, I've kind of changed the title a little bit. The reason is that I actually just joined DataStax last week. It's been, a great place. Learning a lot of things, and if you're familiar with DataStax, they are the ones that are the commercial company behind like Apache Cassandra, so the NoSQL database, and catered more for the big data kind of user, right? So anyway, so they're expanding, and then essentially supporting streaming. So streaming is, again, I'm going to get into detail, but as I'm kind of looking at this too, I'm kind of getting a good sense of appreciation of, what I'm going to talk about really is more about the event streaming side for best of all worlds. Yeah, not just, at first I thought, okay, two worlds, there pops up, and messaging, yes, a message queuing. So now it's actually more like for all worlds. And why? So I'll kind of reveal to you as I'm getting into the details of this presentation. So thank you very much again, and let me start. So who is Mary? So I'm a senior developer advocate at DataStax, and I'm with the new streaming team. And as such, too, is event streaming for big data. So at DataStax is a leading data management company that is actually building, too, for cloud native. They are the first kind of commercial offerings for having Cassandra on Kubernetes, too. So. And I'm actually based in Chicago, so kind of same time zone as you. And I have been to Kansas City a few times for KCDC. It's really a great event too. And I'm also a Java champion, and also the president and executive board member of the Chicago Java Users Group. I'm also active with other communities in the Chicago area. I was working for IBM before, so I'm still actually involved with the community in Chicago too. And if you're interested ever to come to us Chicago Java Users Group, CJUG, please join us online, and I can give you the link to, or you can find us on meetup.com, or search for us, or follow us on Twitter at CJUG. So just a bit of an advertisement. Oh, okay. And then before me becoming a developer advocate, so I'm currently a developer advocate, and it's as I mentioned, I worked for IBM too for 3.5 years beforehand, and also at another small company for working on MQTT. Still kind of pops up IoT messaging. So that's my area experience doing developer advocacy for 4 years or so. And prior to that, right, I started as a volunteer, CJUG. So I've been doing kind of advocacy type of work for a long time, and I love it. And I love to meet developers. And I also have my own Discord channel, which is right here. And I also have my Twitch live streaming every week on Wednesday too, that I'll give you the information about towards the end as well. And here is how you can also get hold of me on my Twitter handle and also my LinkedIn. So, okay, so that's me. And let's start. So the agenda will be about event streaming. But the thing is too, first of all, I figure it will be good to kind of everybody get in kind of start from the same place. So let's have some common ground of understanding, the many facets of computing events, right? So event streaming, event processing, complex event processing, event-driven messaging. So I'll kind of explain a little of that. And then I'll get into a bit of, pops up, queuing. Those are kind of more semantics of event processing, and then really explaining why event streaming and why this whole eventing thing is just becoming more and more popular these days. And then let me then introduce you to Apache Pulsar, which is an open source project, and if you're familiar with it, Pulsar, as I'm learning, right, that it's really extending the current, all of the other streaming platforms that you have heard of, and primarily in the Apache world, that will be Apache Kafka. I guess everybody knows what Kafka is, event streaming. So it is definitely doing its job, very important library framework and everything, all the things that it offers, also from Confluent, from the company behind it, right, the commercial company. And then also to Apache Pulsar, you can also integrate with other streaming platforms too, but I want to kind of introduce Pulsar as to why this would be the thing of the future that's coming up and coming, and also its dependencies on Apache Zookeeper, which is like for managing cluster, managing like distributed systems, and then also Apache Bookkeeper, which Pulsar makes use of very heavily for the more of the journaling, logging side of things. And then I wanted to explain a bit, right, that there's not like really, I'd say, not so much a competition to say it replaces other streaming platform, but really it's kind of positioned as more of something that can extend the limitations of some of these other streaming platforms such as Kafka. So I would just kind of explain a bit too of some of the things that Pulsar can do for you. So with that, I'll start. The many facets of computing events. First of all, I thought, let me kind of get down to basic, right? What is an event, right? Generically speaking. And also too, let me also kind of point out too, if some of you are already expert in doing event programming, please bear with me a second, because I'm kind of assuming that not everybody comes in with the kind of experience working with events. So I like to get all of us together and just start from a common base of understanding. So what is an event? So for me, right, like let's say, right, without computers, the context of computer too, what is event? So I kind of look up the first best place, right, Merriam-Webster.com, so the Webster dictionary. So first of all, the very basic thing is something just happens, is an occurrence, something that happens, right, event. And then I was like kind of going down the list and I said, this is the fourth explanation is kind of nice, right? Is it getting a bit kind of on the nerdy side based on the theory of relativity. What it says is the fundamental entity of observed physical reality that's represented. What is this reality? It's really represented by a point in space, right? It's designated by 3 coordinates, right? So if you're a math person, X, Y, and Z coordinates. So somewhere it exists in time is a dot. And then the thing is with event is interesting is that it actually also takes in the time kind of aspect too, in the space-time continuum. It's actually postulated by the theory of relativity. So think of it kind of events is a very interesting concept. It's a bit harder to grasp, right? Not like object-oriented in the sense that objects, you can, even though while things are still abstract in the computers, you can't really like touch it. But the fact is, at least an object, you can kind of relate in your mind, okay, well, it is an object, some kind of form, structure, you give structure to it. Whereas with events, it's less of a well-defined structure. In fact, there's probably no structure. It's usually a stream of bytes, right, that kind of flows through, but well, how do you capture it, right? And then that's the challenge. So basically, these data exist in time. and it kind of varies itself, and it changes over time to the state of it. So to me, I find it kind of exciting. Think of it kind of events-driven programming, and makes it all the more exciting to be programming. And I feel that in computer science, right? Like me, I major in math and computer science. When I was studying about it, I first started doing programming. It's always like, okay, we define some structure, we define all these things, and you do everything. Everything is synchronous in nature, because you're like doing a request and then you process it, send it to some function, you wait for the function to come back with the results. Whereas with events, the idea is that things can happen at any time. That's why too is it leverages on techniques such as publish, subscribe, right? Queuing, all these things. And so it takes on a very different semantics too with events. And I think because of that too, it's kind of has caught a lot of us by surprise, because it's just not as easy to grasp. It's just harder in some sense. But the thing is though, if you kind of understand, right, this event concept, in real life, then maybe once you understand it, it actually makes it a lot more easier to kind of appreciate and therefore derive like solution to kind of solve this problem. But I think it's kind of one of the most exciting things to do in computing, I think, right? So, but that's what that's how I get into doing events driven distributed messaging. So, okay, so now let's get a bit then into event streaming processing. So essentially, event streaming processing is really the practice of taking action on a series of data points, right, that originate from a system that continuously creates data. So the events can happen or not happen. It's just basically, time keeps going. If you think of dimensions, right, and it's as kind of represented as a line, so you can have data that occurs at different points in time, and you can have different events, so therefore you can have many events happening and at different points in time. It's sort of like the time thing brings in the fourth dimension into this three-dimensional world that we live in. Anyway, so and let's get back into kind of more concrete. So events, right? Events basically refers to each of the data point in the system. And the stream is interesting, because then stream events is a bit more like a point in time, right? Some event, but the stream actually explains the ongoing delivery of those events. So a stream is essentially carries with it many events. It can be many events, or as small as just one event. You can have the stream just only process one or two things, or can have many things. So just think of it like that. We're representing streams as lines, basically. Okay, so a series of events, right, can also be referred to as streaming data or data streams like that. So that's how we understand event streaming processing. And then there's also the concept of complex event processing. So in general, too, if we kind of look into stream processing, very often we're just looking at, an event stream. It's usually one event. And we're dealing with that, and it happens in time, and that's the event. But there's also a concept, right, of complex event processing. So it kind of extends, beyond just that one stream. It can be like multiple event streams that are together, and we're trying to process them holistically, kind of thing. So if you kind of look into this interpretation, where I think I got it from the Confluent website, they talk about CEP is really a set of techniques for capturing and then analyzing the streams of data as they arrive, to identify. What's the point of that? Is basically identify opportunities or threats in real time. So a lot of things, right, as we are doing today, we're dealing with systems that we know, the threats are happening at any time. So we want to be able to capture and kind of nail it down and identify problems that occur before they cause any problem. So that will be a big kind of a use case, right, for using events type of processing. In fact, many things I think in my mind too, should be leveraging on this event-driven approach, because everything is happening in, a synchronous fashion, right? If we live as human beings, if we do everything synchronously, I bet nothing really gets done, because the idea is synchronous. It's kind of more like you have to wait, you want something, you have to wait. No, but we want to be ordering, like let's say ordering our lunch, and then while we go shopping, while the food is being cooked, and then you come back and get it when it's ready. Kind of simple things. If you think about it, events is so important. But anyway, back to the CEP, complex event processing. So it enables systems and applications to respond to events, to trends and patterns, right? When we kind of get into kind of more of this, more like deeper kind of in-depth kind of event processing, and brings us a lot of advantage and benefits in terms of understanding our data and responding to it as things happen. And it really enables systems to be, we can process data in the real time. Real time thing is also isn't all new, but it's kind of becoming more and more important for doing things in real time. So. Okay, and now then, let's kind of move into the messaging side. So when we talk about messaging, we can have event-driven messaging or message-driven kind of messaging. So there's a bit of a slight difference too between the two. So I like to clarify a bit. So now this also too is taken from Lightband. If you're familiar with the Akka framework, right? The reactive library Akka from Lightband, which is the company that makes Scala, yeah, right? The Dr. Martin Odersky company, right? So anyway, so they are also the leader in the reactive principle, reactive manifesto. Anyway, so I just thought that's a great place to kind of understand more about, some subtle differences between event-driven and message-driven messaging. So event-driven, essentially, too, we deal in general, we look at it as like, okay, events, sender, we always have somebody that produces the message. So we call it a sender or producer or what you call publisher, right? Publishes, admits messages. And basically, too, the sender, he or she doesn't care like where I'm going to be sending the messages. It's more like I'm just kind of sending out messages. And for those on the receiving side, if you're interested, you can subscribe to the topics, right? In general, when we talk about event-driven in a pub-sub type of semantics kind of world, it's about publish and subscribe. So in that case, it's the subscriber will have to be responsible for subscribing to the messages in order to receive any kind of messages that are sent out by the publisher. So that's an event-driven messaging. Now, whereas in message-driven, basically the sender and the receiver, you have to be known to each other. So the address, of where the messages go to will have to be known to. And of course, too, a lot of the libraries, too, kind of will make it, for example, like Akka, and makes it location transparent, things like that. And you can also kind of programmatically do that, too. But the idea is that still, whether or not, you know the address or not, it has to have an address that kind of identifies where the sender is, where the receiver is. So then when you send it, it always goes to each other. So that's message-driven. So kind of the subtle differences between the two. Now, then let's kind of go back a little bit. Before event processing, right, what do we have? It's basically batch processing. And I'm sure, too, some of you or a lot of you, too, have worked with batch systems, and they are still very commonplace today. And they are in general, too, right? For example, I'm sure, you have a lot of subscription to the different systems that you use every day, right? Like insurance, for example, insurance systems, or something like your car insurance, or what other thing? Oh, okay. So, say a company too. We can have employees kind of making updates to it, at any given point in time, the vendors, whatever. This information system, they are kind of more like systems of records, right? So those things, they don't need to be so much of a time kind of sensitive to it. So you can actually, you batch things up. And very often too, right? Sometimes when I try to log on to my credit card company over the weekend, I know that they probably are doing some maintenance and perhaps some batch processing, or maybe not just weekends, sometimes during the day at nighttime, batch processing can be happening. So batch is more like you kind of gather all your data and then you crunch through it, at some kind of designated point of time. And of course too, then it's a lot slower. But the thing is too, not everything needs to be kind of real time. So things like systems of record, you can kind of wait and then do it at night and kind of offload so you don't take up computing time during the day. So that would be more batch processing versus event-driven kind of approach. So okay, so that's that. And then now let's kind of get into the event messaging semantics and patterns. So I already kind of brought up too is the streaming side of things. So when we do streaming, we essentially also kind of make use of, if we think of it, events are coming in as streams, they carry with it all the data, streams of data coming in. And we usually then this approach that we want to use will be a pub-sub type of way of doing things, publish and subscribe. And Also, too, for PubSub, it always like require a broker in the middle. So the broker, think of it like an agent, or even think of it like a post office, right? And if I'm the one that's publishing, sending out the messages, I want to do publish, and basically I don't know, I don't care about what the address is, the receiving side. I'll let the broker deal with it. So in order for you to be able to put a label on the messages, so then the subscriber would know who to subscribe to or what topic. So we basically have some topic, and basically you kind of think of it, go to the post office and tell the post office clerk and says, okay, these are all the messages, these are my topics, kind of do whatever it needs to do. But of course, that's a simplified kind of way of talking about it. But essentially, that's how it does its thing. But in reality, too, of course, your broker will have to handle a lot more things. For example, right, a PubSub system. I actually also recently worked with MQTT, which is for IoT messaging, right? And that's a very popular PubSub protocol. So the broker itself actually is an intelligent broker because basically the client side, whether you're a publisher or subscribing client, you have to specify, for example, some guaranteeing message delivery called QoS, right? Quality of service. All of these things you have to kind of configure your message to be. And so it's up to the broker to help you deliver it as things happen. The broker will kind of do things. For example, do you want to retain the messages? And there's also this last will messaging and all of these kind of specific kind of things that you need to associate your messages with, and the broker will take care of it. So that's the broker, the kind of function of the broker. Broker tends to be also can have some intelligence built in, right? Can have a lot or not so much. But essentially, it helps you deliver the message so that when the publisher sends something, then the broker has all the information. It goes to this topic, then it will be there, and then distribute it to the clients that have subscribed to that particular topic, right, for those messages. So that's what PubSub is. Now, there's also then the other thing, the semantics, right? And there's also message queuing. So the message queuing, too, is a form of asynchronous service-to-service communication used in serverless and microservices architecture. They are commonplace to use in queuing in microservices, right? That's so common now. And messages are stored in the queue until they are processed. They get picked up, and then once they are processed, they will be deleted from the queue. So it's more like last in, first out kind of principle. Those are the queuing, right? If you have Sunday data structures, you understand queuing is last in, actually first in, first out, right? Is that right? Yeah, first in, first out, kind of you queue it up. And so, sorry if I said something wrong. So each message is again being processed only once by a single consumer, and then it can be used to decouple, right, the heavy duty processing to buffer or batch works or to smooth like spiky workloads. So that's queuing. Okay, so about some more about event streaming. So what's driving this change, of streaming? So basically, streaming helps a lot too in the real-time processing, right? And basically, we all know that, we live in this modern world, cell phones and communications, everything. We want to look up information and get it right away. So the real-time demand for all the data to enhance our customer experiences that are really driving this change that we want things to happen quicker. And that helps you from a business point of view. If you have systems that can respond quicker, that's always, at an advantage. And then another thing too is that in the application area, as we all know too, things are more sophisticated nowadays. There's AI application, machine learning. They're crunching through huge amounts of data, right? And so in order to process those, actually, my understanding is that right now, a lot of the AI and machine learning, they're still kind of batching up a lot of their data for offline processing, so to speak, right? Not like real time. But the thing is, too, there's a lot of potential in this area to actually have AI and ML, machine learning, those algorithms be processing data as it happens. So that's kind of like in data pipelines, too. And that's when we can think of using an event streaming type of approach to help with it, right? And basically, for example, like time series event streams and things like that. So that's a huge kind of, we're starting to see a lot more demand and understanding of how to combine like real-time event streaming for AI and machine learning type of application. And we're not talking about not even just what you call like terabytes of data. It could be like petabytes and, really a lot of huge amounts of data. And in order to process that, we need some way of handling this in a very, kind of a really scalable and very fast and responsive way. So using something like, for example, I can quote to MQTT like a broker, right? You can handle like 100, more than that, like billion in like 10 seconds or something like that. It can do it because of the pub/sub type of architecture. You're decoupling the receiving end and the sending end. You can actually scale it a lot faster. So, okay. And then the last thing over here, or the third thing over here, is to the scalability, which I already talked about. So basically, large amounts of data, huge volumes generated by application operating at the edge, like IoT applications will be really good candidate, right, for event-driven type of approach. So. Okay, so over here is just a repeat that I just talked about, right? We want to watch for events with the system or application. We want to subscribe to topics to see certain event types, and then make the decisions on data in real time, not after the event, right? And so we want to be able to ingest high frequency of messages with very low latency, and that's the kind of really the primary goal of why we want to go towards like using an event-driven kind of streaming processing approach. So now I'll enter into this picture is Apache Pulsar. So as such, right, Apache is open source project, and Pulsar is actually a relatively new type of project, not way too new, but it was created by Yahoo. And Yahoo then contributed to the Apache Software Foundation, ASF, in 2016. And then in 2018, it became a top-level project. So right now, too, this project is gaining in popularity. Now, the thing with Pulsar is interesting is that it's, you might say, yeah, there's already Kafka. What? There's another streaming platform. And then there's also Apache Spark, Apache Flink, right? And other streaming platforms, too, within Apache and other kind of projects too. So why Pulsar, right? So essentially too, it's designed from the ground up to be taking on a cloud native kind of catered for the cloud native environment, I should say. So it's cluster based and it's multi-tenant. And also it has a relatively simple client APIs. I wouldn't call it like real simple. Nothing is too simple these days. And right now too, it's supporting for sure, right? Java, if you go to the website, Java, .NET side has C#, and then also Python and Go. But there will be there are also other open source communities that are developing other kind of clients too, such as Scala and things like that too in the JVM camp too as Scala. So, but again, these are kind of just officially supported client libraries you can find on the website, Java, C#, Python, Go, and I think C2 is there. And so, and that's the interesting thing about Pulsar is that it separates out the compute and storage. As such, too, as you can tell, right? If we're dealing with so many events, so many messages that are coming in, and how do we kind of deal with the logging of these messages? There will be a huge amount of data, and how do you store it, right? They are coming in petabytes, right? Not just like billions of records. It's just huge. And how do you deal with it? And so Pulsar, instead of worrying about the storage side, it actually kind of essentially to kind of make use of another framework to do it. And this framework is called Bookkeeper, right? The Apache Bookkeeper to do it. So we'll get a bit into that detail. Okay, so another thing is that with Pulsar, it guarantees message delivery too. So even like, as I mentioned about the broker, right? You have different QoS kind of to kind of support it. QoS, quality of service, right? You basically different types of what you call like a protocol that deals with QoS quality of service of 0. It means fire and forget, right? You just want to send out the messages and you don't worry about getting it back in acknowledgement. Whereas like QoS 1 is you want at least, kind of, deliver at least once, right? And one or more kind of like delivery of your messages. And then the other QoS 2 is interesting. It's actually exactly once. So not more and not less. So there's a bit of a handshake that deals with it, right? Every time you deal with, now we're kind of talking a bit about network packet packet level, right? So you want to do QoS1, and basically you send the message, from your publisher over to the broker, and basically you send the command send, some kind of thing like called publish, and then the broker will have to come back and say, I acknowledge it. That's the normal handshake. But for QoS2, exactly once, it's actually got 2 rounds of back and forth too. So that guarantees the message is only delivered once, kind of like that. So that's just a bit of detail. If you want to know more, I can talk more later too. So okay, so that's very important too. In fact, for event messaging, as you know, right, events kind of like doesn't take on any form. It's just think of it data points in time. Then how do you track it, and how do you guarantee it needs to be delivered? So that's why that's a very important aspect of any kind of event-driven event streaming platform too. It has to handle guaranteeing message delivery. Okay, and then another thing is basically Pulsar also has the serverless functions framework. It's called Pulsar function, simply like that. And it helps you to create that complex processing that I talk about, complex event processing kind of logic with the functional approach. Pulsar also has that too. It's lightweight and it's serverless too. So, and essentially it helps you to build your data pipeline. Okay, and then there's also another kind of a bullet point about Pulsar is that it has a tiered storage offloads too. So it's basically it can offload data from a hot and warm storage to the cold and long-term storage to when the data is aging out. So it kind of helps you. So in some sense, it's kind of nice. So if you think of, very often we as developers, we kind of don't want to deal with this kind of data movement as much, honestly speaking. I still remember as a younger developer myself, when I first entered the field, it's like, oh, what? I have to deal with this data and then dealing with the archiving and auditing all these. This is just a kind of a pain in the neck, because then it's kind of just kind of crunching through all the data and how do you move in data in and out and all these things, right? I mean, nonetheless, it is of absolute importance, and that's our bread and butter, right? We are kind of guardian of the data. We need to make sure, things kind of preserved and they don't kind of get just kind of corrupt data, right? We don't want that. But interestingly, so one thing to point out is that Pulsar and also Cassandra too. In fact, Pulsar is actually also supports Cassandra quite well too at DataStax where I work with. So, but Pulsar too, the whole approach is we're taking this CAP theorem of eventual consistency. So the accuracy may not be as urgent as the speed of you to deliver your data. And we eventually too, we believe data will be consistent. It is what it is. So I just want to kind of bring this up. But anyway, back to this tiered storage offloads. So that's when it knows when you can kind of offload the data to kind of long-term storage, things like that. You can rely on Pulsar doing it for you without you having to deal with it, especially if you're in a cloud environment, right? You're dealing with already like so many things, Kubernetes, containers, all these things. Pulsar actually helps you out with some of these things. It knows that you need to worry about managing these data, for long-term storage, things like that. So think of it more like a Pulsar as an extension to the current. If all of these current like event system, all of these things, they are too busy doing the work, but Pulsar already thinking ahead that we have all of these other managing aspects that it will help you to do that too, especially in this complex cloud, chaotic world, let's put it that way. Okay, so now then what is Pulsar, right? So you're like, okay, I talked for a long time. So essentially too, it is, think of it, a unified distributed messaging and streaming platform. It is open source, is originally developed at Yahoo, I mentioned earlier, and blah, blah, blah. It's top level project now since 2018. So it's still quite new, in fact. So there are multiple companies too. If you search for Apache Pulsar, you might actually find a lot of information from Stream Native, this company, and they are actually really gung-ho, all on Apache Pulsar. This is all good, don't get me wrong. They're committers and PMCs on Apache, the project itself, and so is DataStax too. We also have committers and PMC members in there too. And then there are also some other companies too. But essentially, I'd say we're kind of the biggest vendors out there that are that actually have a stake, right, and committing to it. But we separate out the commercial and the the open source side of things. So we try to do everything as a community-driven kind of process. So. Okay, now Apache Pulsar too, as I mentioned, also is cloud native ready. There's Kubernetes, we support that, and also it supports. The nice thing about it is multi-cloud and also like hybrid cloud. So all of these cloud thing, it kind of figures things out for you. So as you can see over here, I'm just sharing a couple of graphs in here. It's just showing you between 2017, right before it became a top level project, or once it became one in 2018, it was about 1.7K or so of GitHub stars. But now if you go there, it's actually 8.8K. So it's showing that people are starting to understand it and appreciate what it is going to be used for. That, it's really for the modern days, that, kind of days that are come to. And number of contributors too also have increased, right, from 46 in 2018 to now like tenfold, like 400 or more committers now. And monthly active contributors, as you can see too, is actually we're getting more contributors, like say when we compare with Apache Kafka too. So. And who else is using Pulsar, right? So look at this list. There's actually getting more and more companies, especially the big ones that are using Pulsar too. And as I mentioned, actually, yeah, I forgot to about Splunk. They are also a big contributor to Pulsar. They are using it. Yahoo, not to forget them. They're the original contributor, the initial originator. Comcast and GM, all the other companies too. They are in China too. Verizon, not China, but Verizon and all these. And this is just a marketing slides I just thought I'd show. Is basically the Apache Pulsar has up to 81%, right? Kind of lower 3-year cost compared to Kafka. So just thought I'd share about this. And it's got 35% higher performance, 73% savings for high complexity scenarios, and 81% over here is like savings for higher data volume scenarios. So. And a brief history. I think I already did that. Why did I do it? But this actually is some of these are from company, right? We're trying to come up with some kind of common slides. So, okay, so I already explained about this is cloud native, distributed, unified messaging and streaming platform, open source as Apache top level project since October of 2018. So, okay, so I won't get into all the details here. We already talked about it, but the latest fixed version is actually in December, so roughly 3 months back, and December of 2021 is the latest release with the Log4j 2 fix 2. So, and Pulsar is different. So let's kind of iterate one more time about some of these Pulsar components, get a bit more into detail. So Pulsar component, right? I talk about pops up. So that's producer and consumer. Producer are the ones that is the one that send messages to topics that are managed by the broker. So in this picture, as you can see. So as such too, this is a complex ecosystem. We can cloud native, everything is clustered. You have multiple copies of the brokers running. Zookeeper will help keep everybody kind of behave properly, so to speak, right? Kind of as such, right? Zookeeper, what a good name. I was thinking, it's like chaotic. You get all the animals around, but Zookeeper keep them in sane. Okay. And then there's consumer, right? So consumers are the ones who will be interested in these messages that are managed by the brokers as sent to by the producer. And broker essentially too is a stateless process, right? That handles incoming message and message dispatching, communicates with the Pulsar configuration store, and then stores the messages in bookkeeper instances. So think of the broker is actually doing a lot of work in here. It serves all the data, manages all of these things, Bookkey. So Bookkey is essentially the name for bookkeeper. So it's Apache bookkeeper project. And it helps with like persistent message store. So as I mentioned earlier too, is that, we're dealing with events. So there are like tons of messages coming through the system. So if you get the broker, let's say if we have Pulsar also manages how do we store them, it will be a lot more work. And also it slows you down too. So we kind of like offload it to a project, another running server bookkeeper to actually helps with that. So as you can see, the Bookkey, right? They partition off some of the topics that get partitioned off, and then also it segments out all of the storage, all of the data too, and it manages things for you. And essentially too, it has a idea, right? If you do bookkeeping, it's just think of like business, any kind of without computers, you have to do bookkeeping. It's a lot of work, a lot of paperwork, all of these things. So it's the journaling side, right? It enters all of these information. There's also different things too that it handles as far as like bookkeeping, journaling from that perspective. And then there's also Zookeeper, which I already talked about. It hosts the cluster metadata, handles coordination tasks between all of the Pulsar clusters too. And so some of that, just get a bit into the design principle, is a tiered architecture design of Pulsar too. Is if you kind of take a look at this, is traditional multi-node architecture, and they are distributed architecture that supports horizontal scaling too. So it's not just like vertical scaling, right? It's horizontal. If we find out there are a lot more messages coming, we have to kind of spin off more brokers to serve them too, that type of stuff. So, and then as I mentioned too, topic too, there's abstraction. There's also a partitioned topic abstraction, and it makes it masks the complexity from the consumers too. So from the consumer side, I don't really worry about these if this partition or not partition. We basically have the mechanism of handling that aspect for you. So from the consumer side, I'm just subscribing to some topics I'm interested in. I know that I will be guaranteed to receive the messages because the broker will also help in kind of guaranteeing that. So. Okay, and some common challenges, right? So again, when it comes to, scaling, if it's just one thing, just a few events, it's not an issue. But the scaling can become complex if you're dealing with, your horizontal scaling. You need to scale up your system and spin off more brokers, that type of things. So, and then because of that you need to rebalance everything, right? If you have this broker already managing certain number of events and another broker comes up, I need to do the work. You need to have some mechanism to handle rebalancing all of the partitions. So basically, the scaling part will require this too. So Pulsar has this built-in kind of mechanism to handle the rebalancing all of these things for you. So on the application level side, we don't need to worry about it. And then there's also like tightly coupled persistence and messaging serving capabilities will have like impose kind of like high costs on historical data. So that's another aspect of it. But because of Pulsar's way of handling things, it doesn't, we don't have this tightly coupled, right? There's no, basically, the persistent side, we're handling it by bookkeeper like that. So that there's not that tight couple thing involved. And then the trade-offs to support like partition topics came at the expense of messaging semantics needed for use cases such as queuing too. So interestingly too, that's another point I wanted to point out, is that because of Pulsar's kind of unique kind of architecture, it supports PubSub. It's very obvious in here, but it also then can support like queuing too. On the topic side, you can actually turns off the topics into queues as well. So that's kind of another kind of unique feature of Pulsar. Okay, and then let me also get more into this. And so then you might say, well, okay, so what is the big deal, right? So let's kind of take a look into more of this. Basically, too, it's fast and low impact horizontal scaling, and then also it helps to reduce, all of your expenses too, because of how it is structured, especially in a cloud native kind of scenario too. If you think of in a cloud, in any kind of like cloud deployment, right? You get charged by how much you use computing resources. But the way Pulsar is organized, so then you kind of basically minimize your cost of having had to consume too much of the cloud resources, because then itself too already kind of make things more efficient for you, so to speak, on more of the plumbing kind of perspective. So okay, and then there's also broker is stateless. It's got built-in load balancing and then instantaneous scaling too, and essentially to even disaster recovery, right? Because of the way how it is doing things, it's built-in resiliency. If one broker goes down, you have another one that can pop up and overtake it too. So it is kind of got this zero impact disaster recovery kind of mechanism already there. And then Bookie too, a word about Bookie, the bookkeeper, is scalable and also wall-based. So wall-based is essentially a sort of protocol. It's called write-ahead logging kind of a mechanism. So think of more like a journaling. What it does is that the way it works is that you have tons of record coming in. So the logs. So instead of writing your logs directly to the database right away, it has this intermediary steps. It's basically called you still store it to storage first, and then kind of clean it up first, essentially guaranteeing it first before you actually enter it into the database. So that's kind of a wall-based, kind of in a nutshell, that's what wall-based is. But it's a common techniques that's being used in journaling kind of work. So already Bookkeeper has this kind of a mechanism that helps with the guaranteeing, all of these messages, making sure log messages, logging is being, kind of like stored into database, like final resting place kind of thing. So okay, so Bookie too also is fault tolerance and low latency, kind of offers you that level of service, and it's also tunable too. So it's pretty nice too. It's consistency for message replication. Some of these things I'm kind of relatively new to this too, but if you want to read up about these, ensemble size, write quorum, acknowledge quorum, all of these things too, if you want to read up on that too, is something that Bookkeeper also has that already built in. And then there's this fast write guarantee through journals, as I mentioned about the journaling too. It's actually very performant to this whole idea of the Bookie, and then it also is manage itself in clusters kind of format, right? And it's segment out, the segment centric, right? Data persistence via ledgers too, like that. So okay, so that's the Bookkeeper. If you're interested, maybe at a future meetup I can do, let me kind of study some more. I'll get more into the Bookkeeper side if you're interested. Okay, so then what are the thing that Apache Pulsar is trying to solve, right? Essentially, too, we call it like bolt-on, right? So you represent the next generation of enterprise messaging. We don't come in to disrupt the current, so to speak, ecosystem, right? We have, let's say, right, at any company, you are on premise, you're already running Kafka, you have JMS, you have RabbitMQ, all of these things. Basically, too, you can just plug in Pulsar. We play nicely. We come in, instead of disrupting the piece, we actually going to help you to augment what you already have. Kind of think of it like that, right? So you can continue to have your system still be on premise, but Pulsar comes in and gives you advantage of more things, essentially. So essentially, too, that's why it's best for all worlds. And look at, right, it is a unified solution for PubSub, for queuing, for streaming, and then also for even the message mediation and enrichment, right? So message can be traveling, like events, right? Carrying it with the data, those are the messages. You can actually transform the messages as you are flowing through the data pipeline as well. So Pulsar has this capability too. And also, too, the out-of-the-box capabilities will include like cloud, like on-premise, as I mentioned already, on-premise and hybrid. And it also has this thing I wanted to highlight, the georeplication. So you can have data centers that are running in different parts of the world, right? That's why there's georeplication. You have one, in the North America, another in Europe, in Africa, in, South America, all of these things. And basically, it already has capabilities of helping you to do replication among your different data centers. So that's kind of a big plus too. And then also the multi-region support. So think of, right, sometimes it might be easy if everything is the US, but guess what? Now in a global stage, we have systems that are running in Europe. And for example, this is an example, right, of GDPR, right? And if you're familiar with that, kind of dealing with data privacy is a big thing now in Europe. In fact, it came out a few years back, and a lot of companies are now even like outside of Europe, but companies in the US, we're doing business with Europe. We need to respect to the GDPR when we're handling data, things like that. We have to respect those things. And so basically, in Pulsar too, you can have different regions of handling these different kind of requirement, things like that. You can actually configure so then Pulsar can, basically have things that you send in to doing certain functions and guarantee data privacy, all of these things too. So, and then there's also on the data mining side, you can do data lake integration and much, much more. But of course, too, I do have to also say, a lot of goals are being also set in Apache Pulsar because it is very new. We are working towards those goals. But the thing is, too, we definitely are set out to kind of help to solve a lot of problems that otherwise would be kind of a pain in the neck to do if you're a developer, to deal with some of these aspects of computing. Okay, so this actually also is just another repeat of this, the previous slide, is unified platform for all events in the enterprise. And okay, this is also another kind of diagram to share with you. As you can see, right, over here, the left side I show you is bolt-on, plug this whole thing in, kind of put on top of what you have. But on the right side too, if you kind of think of it like that, right, it's using Pulsar as a unified enterprise messaging and streaming back backbone to, you can think of it like that. So if you're already running Java, running Kafka, having MQ, all of these existing producers, consumers, already they have its own kind of subsystems, events thing. We're not going to disrupt your piece. We're coming in and we kind of augment what you have, and we have the Pulsar in here. We kind of think of it Lego pieces. We bridge you to other systems within the entire ecosystem easily too. So as you can see, these are like the example representation of a huge corporation. For example, you can have so many different implementations using different libraries and all of these. Using Pulsar, you can actually use it as a universal kind of a messaging kind of a hub, kind of, so to speak. Well, not really a hub, but I'm just using that word, that you can use that as the central kind of a coordinator, right, so to speak. Kind of really think of it as a peaceful kind of entity to come in and help you kind of thing. So. Okay, so now how is Pulsar different, right? The next generation of architecture will provides distributed tiered architecture. It separates out compute from storage. So that's the kind of important thing here, because it separates out the compute from storage. So it makes actually the scalability side and persistence resiliency a lot more easier to manage from that perspective too. And Zookeeper holds the metadata for the cluster. And then there's stateless broker handles producers and consumers. And then the storage side, right? We separate, okay, the compute is the broker's responsibility. Apache Bookkeeper is the one that handles the storage side of things. So it's just a repeat of what I already said. And over here is just another diagram that I actually got to. There's some marketing materials, but over here, as you can see, you can plug in anything, and Pulsar can always be augmenting what you already have. So. And here, some features, right? I again want to kind of highlight, right? Pulsar is rapid patching, and you kind of offers you zero downtime because of how, if you need to upgrade anything, basically there's no downtime. Everything is replicated, is clustering, and it takes care of things, auto scaling or rebalancing, all of these things. So if you have some components down, is another part of the system can still keep running, and it will rebalance all of the situation for you. Your topics are being partitioned, okay, no problem. Pulsar will come in and rebalance it, so then you make sure that the topics doesn't get corrupted, things like that. So, and then there's multi-tenant, right? So essentially is soft isolation via read-write I/O separation, independent storage quotas, and message flow control, and throttling mechanisms too. So basically here too is hard isolation via physically separate brokers and or bookies or tenants too. And that's what the multi-tenant means. And it's really ideal for a cloud environment. And then there's also the identity and access management. So we kind of support too, right? Pluggable authentication too. We support like TLS, the SSL, like TLS, right? Authentication, JWT, JOT, right? And OAuth 2.0, Authents, Kerberos. There's also role-based authorization that provides control at the cluster, and then cluster level, tenant level, message producer, and consumer level. So we can rely on role-based authorization as well, in addition to the authentication. And then as far as data is concerned, we also offer end-to-end encryption. So in-transit TLS encryption and application managed content encryption too. So data at rest and in transit, and also let's see, data at rest and in transit, and there's one more. There's, well, anyway, data in travel. Anyway, I think you got my point. So okay, let's see, one more. And okay, so just wanted to kind of point out again, right, what are the key differentiators, right? Why do we then have another streaming library and other options? Why, right? We try to understand why. So again, I already pointed out is the separation between compute and storage. So basically over here, right, it's just a repeat, but looking at the picture in here is that it makes it easier because you're offloading a lot of the work that otherwise the broker would need to do, or maybe your whole configuration, your cloud would need to worry about, right? The compute, the storage side. So again, right, storage things, it has its own complexity. So instead of us doing it, we'll have Bookkeeper handle things for us, because then it manages all of the log data, and it manages if it needs to spin up additional, bookie and all of these things. We'll let the bookkeeping side worry about the storage, your separation of concern. This kind of approach makes the scalability side of things easier in that sense. So. But of course, too, I also have to say, I mean, as developers, we know nothing is ever simple, right? We're kind of shifting some complexity. We may say, okay, we break things away from one, but the complexity is still there. We still need to solve that problem. But in this case, the storage side, we'll just have bookkeeper, the specialist of the bookkeeper, to handle the storage side. And then we have mechanism of coordinating the two between the compute and the storage. So. And then the next thing, right, besides the separation of compute and storage is georeplication. As I mentioned earlier, too, you can have hands-off and real-time message replication across different data centers, right, in different regions of the world and different geographies. So, and over here, too, the message replication mode and patterns, you can have synchronous kind of replication or asynchronous or active or active passive, this type of patterns for replication or selective message replication. So all of these things too, it's very flexible. We kind of Pulsar supports that too. And it's basically the nice thing about this too is that this capabilities over here, the third bullet point, to meet data compliance requirements across different geo and regions. As I mentioned, right, in Europe, as GDPR is one of the things, and I think in California too, I heard in the US, they're also coming up with some new kind of requirement too to handle different types of data compliance, right? So you can implement that maybe only for like data sets that are in California, and different rules to apply to Europe based on their requirement, their legal requirement. So that's georeplication. Oops, I think I go a little too fast. And the next thing is the multi-tenancy too. So basically, we consolidated the messaging and streaming platform, right? And basically, from an operation point of view, it's a bit more simpler in this kind of sense too. And if you need to kind of have in your cloud kind of infrastructure, you can have multiple tenants, right? That kind of all like exist within the same cloud infrastructure. You can handle different tenants too. So over here, you can have a Pulsar cluster, and you can have, or even within the same company too, you want to separate out, right, the different tenants type. And one is, this example here is a tenant is a finance department, and you can have different namespace that does different things, right? You separate out the different kind of like functional kind of needs, right? You kind of logically separate things out doing this multi-tenancy approach. And then you can have another tenant that's handling marketing stuff, and then underneath it has different namespaces to do their different work. So it's like over here, an example of tenant 3 has products, and then there are different namespace for handling different things. So. And over here too, it's got also, now once we kind of do multi-tenancy, we also have to then handle permissions type of thing. So there are also permission control within the business domain context too. So security, compliance, and auditing, all of these things, basically because we support the multi-tenancy, you can actually easily configure things accordingly too. And then over here, better IT resource utilization and reduce total cost of ownership. But these are kind of more like business kind of requirement, storage quota, message flow, control and throttling mechanism. And we basically have physically separate out the brokers and our bookies for tenants as well. So. And then another thing, as I mentioned earlier too, they're flexible messaging processing model too. So out of the box, like multi-subscription modes, such as like exclusive, over here is showing you exclusive kind of messaging delivery will be, kind of like you have kind of dedicated subscription for some consumer, right? Or you can also have this mode is called failover, which is you define like two consumers for the same subscription, but only one is think of it as like primary. So only if during scenario of failure, then it goes to the next consumer. And then the other kind of an interesting kind of concept is this shared subscription too. So shared subscription is very useful, especially in a cloud type of cluster kind of implementation, because you can have subscription. There's only one subscription, but they are being shared among different consumers that are kind of all kind of listening for the same kind of subscription too. So that's that. And then there's also a Keyshare too. So Keyshare is basically then is key-based shared subscription too that you can do. So these are like different mode of message processing that Pulsar will support too. And it's basically it's a good fit too for queuing use cases. So that's why to Pulsar is kind of like positioned more to also to support the queuing aspect. And over here, there's a note about Kafka has challenges doing this, because the thing is with Kafka, and I'll go to the next slide and then we'll talk a bit about why Pulsar would be better. And it's just a better alternative to help Kafka. Think of it like that. So, okay, here we go. So why Pulsar, right? So it is very flexible. And also wanting to share with you too, there's on Confluent, actually, there's a write-up to it's about Kafka versus Pulsar. So if you want to read up about it, it's basically very flexible and can act as a distributed log like Kafka, or a pure messaging system like RabbitMQ. It has multiple types of subscriptions, several delivery guarantees, retention policies, and several ways to deal with schema evolution too. And then there's also another over here, the second block too is somebody that wrote about Apache Kafka versus Apache Pulsar on event streaming too. So if you want to read up on that, and why you should consider Pulsar, because when you need like queues, like both queues, such as like RabbitMQ and stream processing like Kafka, you want to have both. You may want to consider Pulsar. And then you need easy georeplication. Multi-tenancy is a must, right? If you want that, so Pulsar is more position itself more like for larger kind of enterprise type of scenario. And if you need to persist all of your messages for a long time and you don't want to offload them to another storage, and basically look at it, Pulsar is really nice. This log storaging system is really kind of offload some of these trouble from an application development team, for example. And performance is critical for you, and your benchmarks have shown that Pulsar provides lower latency and higher throughput too. And then let's say if you are running things on-prem and you don't want to like deal with setting up Kafka and all of these things, you may want to consider Pulsar, because it's just an easier, I should say, not that easy, but you can have it kind of bolt on and handle things for you while you continue running your existing infrastructure. Okay, so and here's just a couple slides just to show you at DataStax where I'm working now. There are different flavors of Pulsar too. So over here, as we can see, right, Pulsar is a unified enterprise messaging backbone over here. So all of these things I've already talked about: binary compatibility with JMS, MessageQMQ, right, Apache Kafka, built for real-time data pipeline. So that's the key, right? This is for real-time kind of processing. Natively too is multi-cloud and is fully open source and built in multi-tenancy, elastic scalability, customer manage. And if you want to manage yourself, you can, or if you want to have it hosted, we also have this thing called Astra Cloud to Astra DB Cloud. It's basically Cassandra build, but we can kind of plug the Cassandra into working with Pulsar through create the streams that way. And I'll quickly show it to you too. And then there's also a self-service developer experience too, if you do like fully hosted too. So, okay. And then Pulsar will meet you where you are. At DataStax, we have what we call Astra streaming. So this is a managed Pulsar platform, and I'll quickly show it to you. Then there's also this thing we're offering like Luna streaming too. So Luna is all free, and you can purchase an enterprise support too for Luna too. Astra is a paid subscription, but Luna is the free one, but you can purchase separate enterprise support. Or if you want to run like all open source, right, use Pulsar, and we also kind of support that. It's all community-driven Pulsar, essentially. And now, just the last slide here is to compare against Kafka, right? And again, right, Kafka, there are some pain points, let's put it that way, right? But Kafka has its purpose, don't get me wrong. I think it does its job. So if you want to scale Kafka, is trickier because Kafka has a more tightly coupled architecture. It doesn't have the separate out the compute and the storage side of things. So Pulsar has an advantage in that. And if you want to spin off another broker in Kafka, it means it has to replicate the topic partitions and replicas, and can be very time consuming. And maybe you have come across that and you find that it's not easy to do. You can do it too, but it's just not as easy to do. So you can think of a framework such as Pulsar that already kind of takes all the headache away from you if you need to do this kind of scaling kind of issue. So Okay, and then with multi-tenancy, Kafka doesn't have, and it doesn't have the multi-tenancy with complete isolation of tenants. And storage can become quite expensive too. And although you can store data for a long period of time, it's rarely used because of the cost implications. And it is possible to lose messages in case replicas are out of sync too. And the thing is too with Kafka, yeah, you can, every time if you have to plan for like as it grows, right? All of these things, you actually have to do things upfront, like plan and calculate the number of brokers, topics, partitions, and replicas ahead of time. And that fits planned future usage growth, right? To avoid scaling problems. And this can be a pain in the neck because before you start the project, so much to be worrying about. And you also have to worry about some of these kind of, so to speak, a bit more like it's essential, but it's also taking a lot of energy. Okay, I need to do this, that. I would rather have somebody manage it for me, so kind of, or manage the dynamic growth as it happens, right? So something like that. And working with offsets can be complicated if you just need a messaging system. And cluster rebalancing can impact the performance of connected producers and consumers. So maybe you get the idea now, right? Kafka then does its job, but if you need to grow in a situation, it might be harder to kind of do that. And if you have to plan ahead of time, it's also not easy to do. So, okay, and then just a note to kind of mention in here, there's this mirror maker georeplication mechanism too. There is such thing, but they are not very ideal. And also at Uber, right? Companies like Uber, they have created their own solution to overcome, but those are kind of homegrown kind of thing, right? It's not like open source, or at least I'm not aware of that yet. So over here too, just a couple more slides to kind of show you, right? This is, we want to express in picture, right? Kafka, don't get me wrong, does his job well and everything. But if we look ahead of time, right, we're dealing with more data. We need to worry about partitioning more, growing and all of these things. So Pulsar is already kind of positioned itself more for the future kind of environment, or not just future, it is already here, I should say. So it's just more ready to handle a more complex world. And it can extend what you already have. So you should consider Pulsar Bookkeeper kind of combination too. So, okay. And over here, I think it's just, again, a repeat compute storage separation, right? Stateless broker, independent scalability, instantaneous broker scaling, disaster recovery, all of these things. And basically over here, segment-oriented log management too. So all of these things. So it's basically helps with the horizontal scalability, much easier too, because it's already designed to handle that aspect of scalability. Fast and low impact scaling and disaster recovery, the storage side and everything. So, okay. All right, so now then where to go from here, and let's keep in touch. But let me kind of, if I have a minute or so, Justin, it's okay, right? If I want to kind of just show.
Yeah, please.
Yeah, it's just very quickly too. I just wanted to show as I kind of talk about the how do you kind of get to Pulsar, right? Working with Pulsar and then DataStax. So if you go to the datastacks.com, it's actually the astra.datastacks.com. I should actually give you the link over here. Or maybe, yeah, actually, I don't have direct access, but I will share the slides with you. So if you want, anyway, if you go to the DataStax, actually, why don't I do this? Go to datastacks.com. And if you go to the website in here, right, let's make it a little bigger. And there's this sign that says sign up to try Astra for free. So this is how you can get to that. And you'll get to this screen, right? And the thing is too, in my case, I've already signed up so I can go directly to sign in. But if not, you can register. And also the nice thing about this is there's no credit card requirement to sign up. It starts in minutes and you get a $25 credit to start with. So you can experiment with it right away. And again, AstraDB is actually Cassandra too. So you can play around with Cassandra too. And DataStax has really good support of Cassandra. There are tons of the documentation too. If you haven't already, right? If you want to learn about Cassandra, we have free courses. There are free things. You can join the Discord. There's also a DataStax developer site. So I can kind of share that with you if you're interested. But anyway, we want to get into Pulsar a little bit, the streaming side. So I'll just show it to you. So in this case, you can sign up. You can also try it out anytime. So in this case, I've already got an account. So as you can see, if I log on here, so this is what you see. But of course, in my case, I've already created a database, and then I also have created streaming too. So that's how you can get to the streaming side of things. So now I have to kind of admit that I'm not expert yet. It's only my second week at DataStax, but it's really a great place. I do have to say. So let me make it a little bigger. So over here too. So you can learn about how to do things. So that's a nice thing about it. I was going to say something. Now I won't have exactly a lot of times, but if you go to documentation right over here, it will actually explain to you what is AstraDB, right? All of these things, and then there are different things too. But this is the managed cloud options too. If you want to develop, and I was going to say, if you want to study about it, right? Actually, go back in here, go to DataStax, go back to DataStax too. There's developers. And over here, how do you get started, right? This is kind of nice. A lot of things, there are videos, and there, how do you try things out? What it explains what is Cassandra, what is cloud native, all of these things too. Now, I do have to admit right now, because the Pulsar, where the streaming side is a relatively new thing. Actually, all of myself, I just joined. Another developer advocate just joined like 2 months before I did, and then also another community manager 9 months ago. So all three of us too are putting together things right now. So, but if you visit this and start learning about Cassandra, by the time you're ready for streaming, that we will have information for you to start more about learning about the streaming side, Pulsar too. So, okay, so here we go. Let me go back in here. What is Astra? So you can kind of look over here, and the Astra streaming, right? And if you want to learn about the streaming side, you can go into here. What is DataStax Astra streaming? Again, Astra streaming is the part that require payment, but there's also Luna streaming, and that's the free one. And you can get enterprise support paid version too. So, okay, I'll go back to here. So please play around with this. And again, you get $25 for credit. And I already created a database, and we support you. It's for free. You can kind of connect to Microsoft Azure. In my case, I'm using Azure, and you can have GCP or having AWS too. All of these things, and then you have to define what is called key base. And a key space, I'm sorry, so to do your work. And then, okay, so I haven't actually got things really going, but if you want to create streaming, you can actually go over here and enter your tenant name and then create things in this case. But over here, right, I already actually create my first tenant in here. So over here too, like after you do that, right, over here, you actually can get help over here, and you can connect, right, and all of these things. You can go to Java, and if you do Python, Golang, Node.js, WebSocket, all of these JMS, you can do that too. So this is, so this is how you can start playing around with it too. And it has, right now, as I mentioned, the documentation may be somewhat limited at this point, but like I said, we're working on it to kind of beef this all up. So please stay tuned for that and all of these other things. So that's what I want to quickly show you. So let me go back to my slides. So since I already talked for an hour, so I think I probably shouldn't keep you for too long. So where to go from here, and let's keep in touch. Okay, let me kind of go back to my presentation mode. Okay, so some resources. So pulsar.apache.org is where you can get information about Apache Pulsar, and the bookkeeper is bookkeeper.apache.org, and then zookeeper.apache.org. And then Astra streaming, and just now I was showing that to you, and then to get information on Astra streaming and then Luna streaming too. And then I wanted to invite you, I mentioned about I have a Twitch stream. So every Wednesday at about 2 p.m. In the afternoon, sometimes a bit earlier or later. And I will be there. Yesterday, I did the Astra streaming, and I was showing how you can connect or launch a Spring app, so a Spring Boot app. So that one is still being recorded if you want to watch that too. But otherwise too, next week is slightly different. I actually have a kind of a very nice person that I worked with, not directly, but we worked a little bit on Raspberry Pi with supporting MQTT. So again, that's IoT messaging, still pops up. That would be interesting if you want to learn about Raspberry Pi and MQTT broker too. This person, Frank Del Porte, he actually has written a book, and also you can find his information, Raspberry Pi with Java. I think he's the one that has written up a lot about Java with Raspberry Pi and then with the MQTT broker and other things too, not just with that. So he'll be on my stream next week, but I may actually do a bit more Astra streaming if there's time, because he's based in Belgium. So he may not be able to stay for too long, but I'll have him. Otherwise, please join me and follow me there. And then I want to invite you to join us at the hood, right? So we have name, right? Because this is really community type of work. My team too, before I joined, they have set up the Apache Pulsar neighborhood. So that's a meetup group. So we're going to have more meetups and having speakers to speak here from other companies and, project committers and the Apache PMC folks too. So, and then there's also a site called Pulsar Neighborhood. It's a GitHub page right now. So we're going to intend to have this for folks to come together and share knowledge too. And of course, you can always go to the Apache Pulsar website. There are also tons of links in there. Like I said, right, project is relatively new, so it may take some time for everything to get more, rich, right? That set of documentation is coming. So please be patient. And with that, I want to thank you, and thank you so much for having spent your precious evening time and sitting in here and listen to me talk. Would like to invite you to join my Discord. As I mentioned, right, I'm not just talking about Pulsar at this point, because I was a Java developer advocate. Actually, I worked with Billy Corando, right, at IBM for 3 years or so, and he's such a great guy. I really miss him, and he can't be here today. But anyway, he was the one that that I kind of keep in touch with, and we did a lot of work too on the Java developer advocacy before. And so I'll be talking about other things. And if you have certain things you'd like me to talk about, you can also ask me to talk about it too. And you can come and join my stream too. I do have viewers that come on board and, kind of on my broadcasting stream. So with that, I want to thank you again, and please stay in touch. And thank you so much, Justin.
Thank you. Thank you for the great talk, and we'll see you later.
Yeah. Okay. Great. Thanks. Are there questions from folks? No questions?
No questions.
Okay. All right. Yeah.
All right.
Let's stay in touch and send me questions on my Discord. So, okay.
All right.
All right. Thanks.